Okay, pretest number 3 for Introduction to Statistics, page 1, question 1. It says the mean weight of a newborn baby in Long Island community is 7.5 pounds with a standard deviation of 1.4 pounds. That means they took all the weights of all the babies in this community, making it the population mean, and they got 7.5 pounds when they averaged them out. However, they took all that data and said the population standard deviation is 1.4 pounds. So this is the claim. Now it says, what is the probability? The moment they say, what is the probability, I'm changing the color in order to answer any probability question. The game plan is normal CDF, the z-score on the left, I'm going to write down ZL for the left z-score, comma, z-score on the right. If you can type that into your calculator, this is going to be the answer to the question. And you're done with that part. Now, it does tell me there is a random sample of these babies. What is the probability that a random sample of 49 babies? They don't even tell you that these babies are part of this community, technically, but they tell you the size of the sample is 49 and that they have to have a mean weight of at least 7.2 pounds. So of these 49 babies, the mean for the sample is at least 7.2 pounds. Now, because you really don't know where this 49 comes from, does it come from this, does it come elsewhere, you're dealing with sample stuff. So when you want to find a z-score and samples, you actually have to do a little bit of an adjustment. So how do we start? First and foremost, here is my normal curve. Normal curve has a z-score of 0 in the middle, but that 0 z-score corresponds with the population average of 7.5. So if I want to know at least 7.2, 7.2 is located on this side. At least 7.2 means 7.2 or higher. So you got to make sure you know that, because at least sounds like you should go to the left. At least is that number 7.2 or higher. So you're actually shading on the right-hand side when it says at least. Now it is your job to figure out what the corresponding z-score is for 7.2. But remember, we got that number from just a sample, and they didn't even tell us where the sample is from. So you need an adjustment. You're actually going to figure out the z-score by doing the sample average minus the population average. But because you're dealing with a sample and you want to find results from the sample, you have to divide by the sampling error. Now there's a formula for that, which I'm going to put to the right before I do this problem. Your sampling error is always the population standard deviation divided by the square root of the size of the sample. So you have enough information. I got 1.4 for the numerator. I got the square root of 49 for the denominator. If you know that the square root of 49 is 7, you can just change that. And you may pick up your calculator and type in 1.4 divided by 7. And if you do, your sampling error is 0.2. That's what's going to go in the denominator. So it's going to be my 7.2 from the sample minus the average from the whole population, 7.5, but divided by the error, because you could be off, and that's your 0.2. Now, of course, I'm going to pick up my calculator and type all that in. So I have on my calculator 7.2 minus 7.5, I hit equals, and then I divide that by 0.2 to 3 decimal, oh no, it goes in evenly, negative 1.5, not evenly, but not bad. negative 1.5. You just calculated the z-score that goes along with that orange dot. I think I'm going to go over it in brown so you can see it okay. So this z-score corresponds with negative 1.5. But the z-score at the other end is always 4, right, when you get to the end. So therefore, how do I do this? Well, in the pink, it says do normal, CDF, left z-score to right z-score. So I'll write down in pink again. It is normal, CDF. The left z-score is negative 1.5, and the right z-score is 4. And I'll use my calculator to round it to 3 decimal places. But I'll be honest with you, I already did it, so I'm just going to round it. It is 0.933. This is the probability for number 1. So you have to know when to take your z-score and divide it by the sampling error, because you're using sample results, not even necessarily from that. All right, that's question number 1. Question number 2. I believe this one has 2 parts, a part A and a part B. So question number 2 says, according to the National Express Credit, the average college graduate owes about $19,000 in student loan debt with a standard deviation of 4,000. So someone did a broad research. That means that's your population standard deviation, the $19,000 in student debt. But their population mean, but the population standard deviation is said to be $4,000. Okay, it says in part A, what is the probability? But once again, before we start, and remember, we're just reviewing. If they ask for probability, you are required to do normal, CDF, from the z-score on the left to the z-score on the right. And whatever answer you get, that's the probability. So keep in mind, that's your game plan. So it says, what is the probability that a random sample of 100 graduates? So now they're talking about 100 graduates. These people may never have even been collected in this data. This might have been done 2 years ago. This is a new set of people. All right, will have a credit card debt of greater than $20,000. So their average debt is not $19,000. Their average debt is going to be greater than $20,000. So their average is going to be greater than $20,000. Okay, so now you know what to do. You got to draw your normal curve and start labeling stuff. So here is my normal curve. A z-score of 0 is right here, and that does correspond to the 19,000. So in reference to that, where is 20,000? Well, that would be on the right-hand side. And if I want greater than 20,000, I want this over. So this is the side that is greater than. It is my job to calculate what that z-score is. Now remember, when you do that, your z-score is going to come from your sample of $20,000 minus what they believed from a study, $19,000. But you have to divide by the sampling error because you're not using a population that's necessarily in here. So there's got to be an error. So to find your sampling error, you take the population standard deviation and divide by the square root of the sampling size. Well, they give you this as 4,000 for the numerator. They tell me that the size of the sample is 100. But you know when you take the square root of 100, you get 10. Now you may use your calculator, I don't mind, but if you knew what 4,000 divided by 10 is, you could just do it, and it's 400. The sampling error is what goes at the bottom. Now when you pick up your calculator and you do 20,000 minus 19,000, you actually get 1,000. And then your job is to divide it by the 400 that is there. But if you use your calculator, you're going to get 2.5. This is the z-score that actually corresponds to this green dot. This is 2.5. And when you shade all the way to the right-hand side, that z-score is 4. So in order for me to answer this question correctly, I'm thinking of the pink, I need to do normal, CDF, and I have to go from the z-score on the left, which is 2.5, to the z-score on the right, which is 4. And I need to type that into my calculator. So remember, it's second vars, normal CDF, 2.5 to 4. Now I know I've done it, but I'm going to round it this time. It's 0.006. And this is the answer for part A. Now, is that all they asked from part A? Yes. So now I'm going to go to part B, but all I can tell you is the blue at the beginning is the same. Okay, so it says, for a sample size of 200. So now we're talking about a group of people that may not have even been in the study. So this time the sample size is 200. It says, what percent of graduates? So I'm going to stop for a second. If they want to know the percent, oh, I want to write it in a different color. Everything in orange will be about the sample. If they are asking for the percent, you have to know enough to do normal, CDF, from z-score on the left to the z-score on the right, and get an answer. But you need to take the answer that you get, which is the probability, and you need to multiply it by 100. And that is going to be the percent. So make sure you know that you have to do that to answer this question. Now, to finish this up, it says, sample size of 200. What percent of graduates would you expect to have a credit card debt of less than $18,000? So the average for the sample is going to be less than $18,000. So you go to your normal curve. You draw that bell shape. Remember, a z-score of 0 is in the middle, and that corresponds to 19,000. So a z-score of 18,000 should be to the left. If I want less than 18,000, I want this side. This is the less than side. So it is my job to figure out what corresponds to the z-score, because the honest truth is, I already know that this z-score is going to be -4. I need to figure out the other one. So what I do is I'm using sample stuff, right? 18,000 is the marker. So my z-score, I guess I'll put it here. My z-score is 18,000 minus the studies credit card debt, 19,000. But you can't just divide it by the studies population standard deviation, because this sample might not even come from it. So you have to figure out the standard error. When you figure out the standard error, the formula is always the population standard deviation divided by the square root of the sample size. So in this case, it is 4,000, sorry about that, 4,000 divided by the square root of 200. Now, I don't know what the square root of 200 is offhand, so I'm going to just type this into my calculator. I got 4,000 divided by second x squared, 200, close the parentheses and hit enter. Now I'm going to round my answer over here, and that is going to give me can I fit it here? 282.843. All right, hopefully you can see that. That is the standard error, the sampling error. So you're going to divide it by that, 282.843. And I'm going to pick up my calculator and I'm going to type that in. So I know when I type in 18,000 minus 19,000 equals, and then divide it by 282.843. My z-score comes out to be negative 3.5, negative 3.536 when you round it. Now if you round it to that, that corresponds with this number, which is negative 3.536. Your job is to figure out the percent. So you need to do that normal CDF. So I'm going to do that, set it up right now. Normal CDF from the z-score on the left, negative 4, to the z-score on the right, negative 3.536. You will get an answer. So second vars, and this is number 2, negative 4, comma, negative 3.536, close the parentheses. Now, the unfortunate thing is that answer has an E in it. So I'm changing the color, and I'm going to put it like this. 171429922E negative 4. Now we had gone over this, so I kind of like center it. I wish I had a little room on the right hand side of the board, but I don't. The E, oh, I forgot to put the decimal point in. The E means go to the decimal point, so I'm right here. The negative 4 means move it 4 places in the negative direction, which is 1, 2, 3, 4. It's now here. It's no longer there. It dragged it across. In those empty spaces, you are going to put in zeros. So that's your number. So you're going to take that number that you have, all right? If you want to round it to 3 decimal places, it's actually 0. And if you take that and multiply it by 100, your answer is just going to be this to 3 decimal places. So I didn't even move it. I just multiplied it on the calculator by 100 just to make sure, but just to go over how to move it in case you need to. Your answer comes out to be 0.017 when you round it percent. Sorry about that. All crammed in at the bottom. And that is the end of page number 1.